To finish off this introductory session, I'll just run you through what happens when we want to execute or run a computer program in memory. I'll then introduce different types and what's called levels or generations of programming languages, and then give you a brief rundown of what else will be in the module. So when we run a computer program, the computer itself, the CPU, can only understand machine code. But it can understand this at a very, very fast rate. Modern processors work at gigahertz, which are billions of clock cycles per second. Now, we don't write programs in machine code because it would be incredibly difficult for us to do so. So we write programs in what's called high-level languages using English-like statements such as the if and the looping statements, which I'll introduce you to later on in the course. And this is known as source code and is readable by people. We then use compilers which build this English type source code into machine code that the computer can then understand, and it's the machine code that we can run. There are another type of programming language called an interpreted programming language which do this on the fly, and languages like that generally reside inside other programs. A good example is JavaScript, which is an interpreted language which runs inside most modern browsers. So the process follows something like this. We edit the source file, which is the high-level language, Visual Basic or C++ or Java, for example, and it's basically a series of text files. We can compile and build our executable program from this source file, and large computer programs generally have hundreds, if not thousands, of source files which contribute to the final product, which can be made up of many different executable files which all interact. So compiling turns the source code into machine code, building finds the system routines that the program needs to execute on its own and links these together into our compiled code, and modern IDEs, integrated development environments, manage this process for us, whereas if we're doing it by hand at the command line, we generally have to compile and then link ourselves. So both of these steps usually appear as one if we're using a modern development environment. So the executable file that is produced is not readable by us. It's machine code full of bytes that don't really mean anything to us unless you've studied it in great detail. However, this means something to the computer and it can read them. So the files are generally a mixture and a combination of data and instructions. So we can then execute a file, and different operating systems work in different ways in terms of how it's executed, but generally a file that is executed in, say for example, a Windows environment needs to have a certain signature of byte patterns in it in the first part of the file which identify it to the operating system as being an executable file. This will then go through and start to load the instructions which can read the data from inside the executable file and carry out the instructions as we want them to be. The different levels of language that you will come across, or may not come across, but might hear about, first generation languages are machine code. Effectively, the early way of programming computers was to do it bit by bit, byte by byte. Developers then started writing programs to make it a little bit easier, so the next level of languages, next generation, were assembler languages, which are starting to use something called mnemonics, which are 3 or 4 letter instructions, and you can directly manipulate the registers inside the CPU. This is still a very, very low level of language, very efficient, but also very difficult to program effectively. You can write small programs easily, but large programs become extremely complicated to write, test, develop, understand, maintain, etc. So generally, we don't use assembler languages these days either, unless it's for something very, very specific. Most modern languages are arguably 3rd or 4th generation languages. So 3rd generation languages are things like Fortran, COBOL, C, Pascal, languages which use more English-like structures in their syntax. So words like if, and you get loops and do's and whiles creeping into the syntax. And then there are the higher than 3rd generation languages, which is a very, very broad level and covers all sorts of levels of complexity. You can get object-oriented programming languages like C++, Java, Smalltalk, for example, and then database languages like SQL, structured query language, which allows you to do some very, very sophisticated things with databases using very English-like statements. And then there are others which sort of combine third generation language features like the syntax with fourth generation language tools that will help you develop something complicated like the graphical user interface. So languages like Visual Basic and modern integrated development environments that support C++ and Java would also fall into that category. So throughout the module we'll have a look at various different types of languages, amongst other things. But principally we're going to be developing simple programming skills, concentrating on the basics, and we will predominantly use languages that are based upon the basic structure. So we'll start with just basic, we'll move on to Visual Basic, and we may occasionally dip into languages like Java to illustrate similarities or differences. The main purpose of the module is to help you understand the principles of good program design. So get these firmly embedded right from the start on your course, and then you can develop your programming skills around this firm foundation. We'll start with procedural programming, writing programs that just operate in a very traditional manner, and then we'll eventually move on to event-driven programming, whereby a graphical user interface can be used to trigger various different parts of a program based upon how a user interacts. We'll develop some problem-solving skills, especially towards the end of the module, as we start looking at algorithms for sorting and searching for data items. And you'll understand that that computers aren't intelligent, and that if we write a program incorrectly, then computers will just do exactly what we've asked them to do, and therefore look like they are getting it wrong. And what you'll understand is that the computer doesn't make an error. It's usually a programming error, but it's very easy to make such programming errors. And finally, we will deal with testing, and testing is an extremely important part of computer programming. Testing should be considered right from the start. It helps you understand the problem, it helps you to be able to have confidence that your solution works and also is reliable and robust. So we'll do quite a lot of work on testing. We'll write initially some very simple programs. Gradually the programs that we will write will increase in complexity and incorporate more elements, and it will become apparent there that we'll need to start structuring our programs and eventually designing and thinking about the overall program before we actually start writing it. So as programs become more complicated, it becomes important to give it a great deal of thought before we actually make a start. And after a sort of first half of the module, we'll move from a simple command line based program in just basic through into graphical user interface programs in Visual Basic or Sharp Develop, which is a programming language, an IDE that enables us to write Visual Basic programs without having to use very large, cumbersome integrated development environments such as Microsoft's Visual Studio. For the remainder of this session, you can find some tutorials on the Blackboard system, which will help you develop your basic programming skills. The final slide of the video will indicate where those are.